All right, so let's start with the f of x is equal to the absolute value of x minus 1. I'm going to box it in pink so we know that's what I'm doing. Okay. Now, first I would like to decide what's happening. I'm subtracting 1 inside, which means this is going to shift 1 to the right, correct? So when I'm picking my table of values, I normally start with 2. But if I'm shifting to the right, then I should start with 1, negative 1. So I'm going to go negative 1, 0, 1, 2, and 3. All right? And I normally end at 2, correct? But if I'm shifting 1 to the right, then I'm going to end at 3. And that just helps me to know where my center is, right? This should be my center if I've thought about things correctly, okay? Where my vertex is. So I'm going to go ahead and do my plugging in. So I've got the absolute value of negative 1 minus 1. So that would give me the absolute value of negative 2, which is 2. Then I do the same thing with 0. So absolute value of 0 minus 1. That would be negative 1 inside of there, which would be 1. And then I do the same thing with 1. 1 minus 1. That's 0, right? Now, if I'm correct, this next one should be what? 1. So let's see if we're right. So we have 2 minus 1. That would be 1, and the absolute value of 1 is 1. Was I correct? Yes, which means the next one will be 2. So let's go ahead and plot those points. Negative 1, 2, 0, 1, 1, 0, 2, 1, and 3, 2. And then draw that in. So if you look at that, normally we start at the center, right? And we said we were going to shift 1 to the right, and that's what happens. All right, so over here, the only difference between this graph and this graph is that we're going to have some sort of stretch or shrink because we're multiplying by this 1/2, right? But it does shift to the right one. But remember when we shift and we have a stretch or something, it still sometimes moves a little bit more. But this should be around about the place where we're at. So I'm going to pick the same numbers, but I'm going to do that in blue. That way we know. So this is the one I'm doing in blue. So I have negative 1, 0, 1, 2, and 3. And we may have to pick another number, right? We're just going to see. But this should get us in the general area of where our vertex will be in the middle. All right, so I've got 1/2, and then I'm going to plug in the negative 1 minus 1. Now, I have a question for you. What's going to happen when we do this negative 1 right here? We're going to end up with what? So we're going to get a decimal, right? So do you think that we should maybe alter the numbers that we're choosing if we want to make it a little bit easier on ourselves? So what numbers do you think we should plug in right here? Numbers that will divide by what? This number on the bottom, right? We want numbers that will divide by 2. So maybe we should adjust our table, and instead of doing negative 1, I could do negative 2. And then instead of doing positive 1, I can do 2. And then what would be another good number for me to choose? 4 and maybe 6. Now when I plug in 0, that's not going to be a problem, right? Because that'll cancel this out. So let's do this I think that will be easier for us. But it's not incorrect if you pick those numbers. You're just going to have to deal with decimals. All right, so if I take half of -2, that's -1, right? -1 would be -2. So if I take the absolute value of that, I get 2. So we're going to do the same thing with 0. 1/2 times 0 is going to be 0, right? Minus the 1 is -1, and if I take the absolute value of that, I get 1. All right, same thing with 2. So 1/2 times 2 is 1. Minus 1 is 0, right? Okay. Then we'll do 4. So half of 4 is going to be 2. Minus 1 is 1, and the absolute value of that is 1. We've turned, right? So right there is our vertex. And that means that when I plug in 6, I should get 2, right? Now if you think about it, half of 6 is 3, right? Minus 1 is 2. Okay? Remember, that only happens if you're going up the same amount every time, right? So plot those points. We've got -2, 2, 0, 1, 2, 0, 4, 1, and 6, 2. This is why I like to use a different color, because otherwise it'd be really hard, right, to see that. So if we compare these two, this one is definitely a little flatter, right? So it maybe shrunk vertically, or we can consider that a horizontal stretch, right? All right, number 6. All right, so first they want us to graph the absolute value of x. Okay, that one is really easy to graph. You really don't even need to pick points. Okay, so what happens is you just start at the origin, and you're just going to go diagonally up. So it's just up 1 over 1, up 1 over 1 the whole time. So if you wanted to put some points there, you could go up 1 over 1, put a point, up 1 over 1. If that helps you get you a line, do that on both sides. So it should connect in the corner of your graph up there. Should go right through the corner. That's our parent function. All right, so now all we're changing is we're adding 2 on the outside. So what is that going to do to our original graph? It's going to move it where? Adding a number to the outside. Up 2, right? I'm going to go up 2. So technically this is going to go up 2. All right? Adding 1 to the inside will move it to the left, right? And multiplying by a negative is going to make it flip, correct? So we could do all of that on here, but that would be a lot of work. So we're going to do the table. Now, when we think about what numbers to pick, we always just think about how we shift left and right, correct? Because that's where we pick x values, right? So if I'm moving 1 to the left, I normally start at -2. So I want to start at -3. And I'll end at 1 because I normally end at 2, but if I'm shifting left, then I'm going to take 1 away from that. And then I'm going to do my plugging in. So I've got negative absolute value of negative 3 plus 1 plus 2. You got to be careful on these. People tend to do them wrong. So do inside of here first. Negative 3 plus 1 gives you negative 2, right? And the absolute value of negative 2 is 2, but then you've got this minus up front. So you really have negative 2 plus 2, which is 0. So don't forget about your little negative on the outside. Then we do the same thing with negative 2. So negative 2 plus 1, don't forget your negative on the outside, plus 2. So negative 2 plus 1 gives me negative 1, and if I take the absolute value of that, I get positive 1, but I still have that negative on the outside. So negative 1 plus 2, which is 1. All right, then I'm going to do the same thing with negative 1. So I've got negative, absolute value of negative 1 plus 1, and then plus 2. So inside my absolute value bars, I get a 0. Is there anything like a negative 0? No. So if I take 0 and I add 2, I get 2. All right. Then I'm going to plug in my 0. 0 plus 1. And then my plus 2. So 0 plus 1 is 1. The absolute value of that is 1, but I've got to take that negative. So negative 1 plus 2, which is 1. See how we've turned? So the next one should be 0, correct? So I'm going to plot those points. Oops, I did them in pink. This should be blue. So I've got negative 3, 0, negative 2, 1, negative 1, 2, 0, 1, and 1, 0. And it actually did what we thought, right? If I started here and I moved up 2, left 1, and then I flipped it, right? Which is what we were thinking. Okay, so for number 7, again, we just got our parent function, so we're going to draw that in. Remember, that just goes up 1 over 1, up 1 over 1 on both sides. You don't need to pick any point values for that. And just start at the origin and go all the way up through your corners. Well, since this is the same problem, I guess we're done.